All right, let me introduce you to a term called a factorial. You've probably seen this before, but the factorial symbol is an exclamation point. Why is it an exclamation point? Well, we actually looked it up last class, and the symbol that was used for it in the past was a little bit more complex than that. And then when people started needing to use this process using computers, they said, why don't we just use an existing symbol in a computer for this process? And the exclamation point seemed to be the best one to use, okay? So that's why. It's an exclamation point because that was a symbol already used on a computer. And what does it mean? What does like 7 factorial mean? It means you take your first number, which can be, you can consider it n, and then you multiply it by each preceding number, n minus 1, so 7 times 6 times 5, all the way until you get down to 1. So if I asked you to find 7 factorial, you would say, okay, well, it's 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? Well, that's easy enough to do in your calculator. It doesn't take you that long. But if I asked you to find 19 factorial, and you're like, okay, 19 times 18 times, and all of a sudden it takes you, a couple minutes to type it in. Your calculator does this operation for you, however. Okay? So to pull up the exclamation points, which means factorial, in your calculator, you'll go math, perb, or probability, PRB. You'll see it to the right on the top, and then you'll select the exclamation point. Now you would type it in, the number gets typed in first, then you select the factorial. If you select the factorial first, you have to insert the number to the left of it. Okay, so figure out what 7 factorial is, confirm that it's the same as 7 times 6 times 5 times 4 times 3 times 2 times 1. If you accidentally select the factorial first, so if I go math perb factorial, but I'm like, oops, I wanted to plug my number in there, sometimes you might have to insert, second insert your values. So there's 19 factorial. And we realize that it's a huge number, 1.21 blah, 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 times 10 to the 17th. Okay, so factorials all of a sudden we realize grow very, very quickly. Okay, 7 factorial we can do. 19 is not too far away from 7, but 19 factorial is something that does not fit on this line. Okay, 5040 is 7 factorial. What we will find is that an acceptable answer to a certain question is this. If you just write an answer as 19 factorial, I will say, okay, you know exactly what to do. You don't have to type that into your calculator. That is fine. Okay? So an example of why we would need to know that. Let's look at example 2, and how many ways can, let's not say 8, let's say 80 different books. How many ways can those be arranged on a shelf? Well, you can either say 80 times 79 times 78 times 76 all the way down to 1, or you could just say 80 factorial, right? It's the same kind of process that we did last class. We'd say, okay, slots. I'd have 80 slots. I'd have 80 choices of books for the first one, 79 for the second, 78, and so on and so forth. Well, you don't have enough space to write out all of those. Instead, you would just say that's 80 factorial. Yes? Right, because 80 factorial is too large for your calculator to even figure out, okay? So it's that many possibilities. How many is that? It's a lot of possibilities. It's not infinity. It's actually a number. Watch. I'll show you.
What numbers come out to trillion?
I don't know. It's not used in society much, so nobody knows. This is a great math website. You want to ask this thing any question, like first names. Sorry that I picked on you, Mr. Champagne. But it will tell you how popular your name is. 52nd thousandth place. 1 in 714,000 people are named Caden. Ethnicity.
Which one's first?
Yes, we did this back in the day. Not that many. They used to do charts. They don't have the charts anymore. Oh, these are last names. Oh, there you go. 189th. There's the chart. Presley has gotten very popular these days. You were probably just at the beginning of its popularity. You were before the curve. Thank your parents for being hip and trendy. Now, I'll tell you that I'm not super happy with this, but look how popular Lola was back in the day, in the late 1800s, early 1900s. So Lola was named after my wife's grandmother. His name was Lola. So, like, it makes sense. And all of a sudden, all these grandparents, like, nobody, it's like, I don't want to, you know, name my kid after myself, but then that kid names their child after their grandmother, and all of a sudden, boop, it's popping back up. So I've run into a lot of people who look like 0.2% of all names are Lola. That's pretty impressive. Anyways, let's go back to something really. I think Matt. Well, let's do John. John's probably been popular. 26. John is decreasing in popularity steadily. It's not unique enough, you know? Everybody's all about the uniqueness. Anyway, so that's cool. But let's go back to what we were doing. 80 factorial is this number. Okay? So there you go. 7.15 times 10 to the 118th. That's a lot of different combinations of books. Maybe just go with alphabetical order. Make it easy on yourself. No, the answer is 80 factorial. That's what I just said. We can use this notation for our answer. Okay? So if a softball league has 10 teams, maybe 100 teams. Let's just go with 10. How many different end-of-season rankings are possible? Well, again, it's 10 times 9 times 8, but instead of writing this all out or doing it in your calculator, you can just say it's 10 factorial amounts. And your calculator probably can get an answer for that, but you can just leave it as 10 factorial. Exclamation points in math. Now, so factorials are used for this purpose, for kind of if there is no repeating certain things, and we want to order every single thing that we have. If I have 80 things, I want to order all 80 factorial. If I have 10 things and I want to order all 10 of them in a row, can't repeat any of them, 10 factorial. Well, what if I have an amount of things and I only need 3 of them? and they have to be a specific order, or 4 of them, or 5 of them. Let's say I have like 20 people, and I want to see how many ways I can select a president, vice president, or treasurer. Let's call that a treasurer instead of treasury. And we can't have the same person holding multiple offices. Well, we would still use the process and the thought process of a factorial, right? We would say, oh, well, if there's 3 slots, president, vice president, and treasurer, I would have 20 possible candidates for one of them, which means that I have 19 remaining candidates for the second one and 18 for the third. Well, there's actually a formula for this process that we just did kind of conceptually, and it's called a permutation. A permutation, this is NPR. If you can't see it, just write it out again, NPR. It is an arrangement of R objects from a group or a list of N objects. So N is my total. Not 20, total. R is my selection. We'll use P because the order won't matter. Which means like we are not just selecting a group of 3, we are instead selecting a president, a vice president, a treasurer, a first place, a second place, a third place. Okay? Well, the formula is just taking the total amount and dividing it by the total amount minus the amount you're selecting. If you think about it in terms of this example, if I had 20 factorial ways to order sorority members, and I divide it by 17 factorial, which is 20 minus 3, what would I end up happening? Well, this would be 20 times 19 times 18 times 17. Keeps going. I don't know what happened. That's not working. Times 19 times 18 times 17, et cetera, et cetera. This would be 17 times 16 times 15. Well, we'd end up canceling all of the 17s, 16s, 15s, and we'd just be left with 20 times 19 times 18. So what I'm telling you is actually this notation can be used to answer this question. This is the same as from a group of 20 people selecting 3. Yes? That's N minus R. N is the total. R is the amount I'm selecting. So 20 minus 3 factorial. It ends up working out to be the same thing as we thought of conceptually. So this is now notation that we can use that might help us if we're talking about bigger and bigger things. So let's look at this example up here. Let's just change it. We have first, second, third, let's say 4th through 10th, and we have 100 contestants. How many ways can we order them from 1st through 10th? Well, instead of writing out 100 times 99 times 98 times 97 10 times, instead we could just say I have 100 people and I'm selecting 10 of them to place an order. And this is what you can write as your answer. Because what you will find is that there's a large amount. Okay? So again, 20 times 19 times 18 is an answer, but this notation is also your answer. Now watch, your calculator can do this calculation using this notation. What you would have to do is select the first number first, go to math, back over to perb, and go to NPR. Everybody do that. You select that, and what it has is the number. That's the number you're putting in for N. PR, you type in the number that you're going to put for R, and you get this. Well, what do we end up finding? This is the same as 20 times 19 times 18, which we figured out conceptually. All right? So it's N first in your calculator, then math, perb, NPR, then R. And then you write in your R. Okay, so it's good to check to see and to gain confidence that this is correct and this is the same as that. Let's look at number 5. How many different arrangements can be made using 2 letters of the word Texas if no letter is to be used more than once? Okay, well, that means I have 2 letters that I'm selecting. Texas has 1, 2, 3, 4, 5 different letters. That means I have 5 possible letters I can choose from the first one. I'd have 4 different letters that I would choose for the second one. That is the same as saying, hey, out of the 5 total people or letters, let's select 2 with the order mattering, meaning E then X is different than X than E. And go ahead and check that 5 times 4 is the same as 5P2. Five times 4. 5. Perb, NPR, 2. Stands for a permutation. 20 is the same as 20. Cool? Okay. Now, what also is cool is that this notation could be used for a factorial. We have 10 softball leagues and we want to order them all. Well, take a group of 10 and order all 10 of them. Type in 10p10 and see if it's the same as 10 factorial. So type in 10p10 and type in 10 factorial, and let's see what happens. Then factorial is that many, taking a group of 10 and choosing 10 of them to be ordered gives us that same amount. Okay? So we actually have 2 ways to express a factorial, either using the exclamation point or using this permutation notation. Okay? Okay. Couple practice problems, and then you guys are going to do the homework. We'll have plenty of time to do that and to check it before we go take our picture. A company issues a questionnaire whereby each employee must rank the 5 items in which he or she is most satisfied. The items are wages, work environment, vacation time, job security, supervisors, health insurance, break time, and retirement plan. That's a total of 8 items.
Thing froze. There you go.
So 8 items, and the question should be, how many ways can we list 5 of the 8 items? That should be ways. Well, 2 ways to do this, of course. Either you could say, okay, I have 8 choices for my first selection and 7, 6, 5, 4, 3. Okay, or you can say it is out of the 8, I want to choose 5 of them. Okay, same as 8 7, 6, 5, 4. That's how many? 2. Okay? Either way works. Now, for certain questions, this won't work. And you should think of it this way with our slots and our number of choices. There's a couple questions on our homework where slots and choices works better than just trying to write it in permutation form and just get it done really quickly. Okay? So know that. We're all kind of ready to just write things out like this and be like, done. However, we need to be careful. Any questions about this one? How much does this equal? Great. Either way you do it, you get 6,720. Keypad lock has 5 different digits to be selected. 5 different digits. 0 through 9 can be used for any number. How many keypad combinations are possible? Well, again, either, and I'll go the other way around this time, 2, 3, 4, 5. 5 digits. We'd have 10 digits for the first one, 9 for the second, 8 for the third, 7 for the fourth, 6 for the fifth. It's the same as starting with 10 numbers and choosing 5 different ones. Now I could change the question up if the first number had to be a 1 or a 2. If all of a sudden I changed the question and said the first number needs to be a 1 or a 2, then all of a sudden I don't want to use this notation anymore. I instead want to go back and say, okay, well that means I have 2 choices for my first number. How many choices do I have for my second one? If I have to have a different number, I would still have 9 choices for my second number. I've used 1 number. I have 9 remaining numbers, so this would be 2 times 9 times 8 times 7 times 6. All of a sudden, once one thing changes like this, don't use the permutation notation. Instead, use the slots and kind of write down our possible selections. It makes things easy. Or what you'd end up doing is actually you'd have 2 choices for the first one, and then out of the remaining 9 numbers, you're going to choose 4 of them. You'd end up with the same thing. Okay? That, I feel like, is more complicated if all of a sudden the question's changed up. Then just writing it out as 2 times 9 times 8 times 7 times 6. Okay, the next example, how many ways can 7 books be arranged on a shelf? 7 factorial ways, which is the same as taking 7 and arranging all 7 in order. Which is the same as 7 times 6 times 5, etc., etc. Okay, next one, 12 runners at the start of a mile-long race. How many possible podiums, first, second, third are? If every runner is equally as likely to win as the other, well, I have 12 runners to choose from. I want to place 3 of them in order. Order matters. This is the same as 12 times 11 times 10. Finally, a new president has to assign people to his cabinet, which includes 15 heads of executive departments and 1 attorney general. Typically, the president has to pick those people from a group of 100 qualified candidates. How many possible choices does he or she have? Go ahead and write down your answer. Let's see what we get. So I see 2 different answers. What is your answer here? I see 100p 15. I see 100p 16. Which one should we have? 16. Why? Because there's 15 heads of executive departments and 1 attorney general. A total of 16 selections from the 100 qualified candidates. This is 100 times 19 times 18 times 17. This is why we don't write it out every single time. Because for a question like this is the easy way to write out your answer. And you could type this into your calculator, and we find out there's a lot of possible selections we can have for this situation. Your homework is the next 2 pages. Go ahead and start and finish this in the time provided. We will go over it. There are 3 tough questions. Number 7 is one of them. We will go over those three questions together. I'd like everybody to work on this. I will be coming around making sure you are working on this. Sure. 7, 10, and the last question, I would say, are the 3 questions that sometimes people get tripped up on. The rest are fairly straightforward. 7, 10, and the last one. There's a couple repeats of answers. Yep, same as 4 factorial, exactly. Whew. Whew.
Number 3 is 50. This is 2, 3 officers. Is that, are those the same or is it 6? The 3 and the captain, co-captain.
No, just the 3.
So that would be right?
Yep, same as number 1.
think I got it.
Close. You're close. It has to be between 100 and 500. So
I know, which means these two get crossed out, which means it's only
no,
between
because
five.
like 565. That's not between. No. We would never have the numbers be opposite like that.
So we'd have to actually fill it out. Reindeer? No. Did you, want to answer them, or can I just write it like
You can just write it like that. What's going on?
Okay, so would it be that and then plus 1, because 500?
No, because you wouldn't have 500, because you can't have 500. You can't have
Oh,
5
no
zeros.
repeating.
Yeah.
Oh, did you want to see it? Look how cute it is. I just sent it to Gracie. All kinds of puppies. Any kind of puppy you want. Look at pink.
Scared of frogs. Scared of pigs. Wants to play with the bunny. Bunny won't play. Bunny's scared. Small one with a big bunny. Wants to play. Bunny won't play. Wants to play with the pig. Pig doesn't want to play. Turtle goes in the shell. Sniffing the duck. Get out of my face. Yes, she doesn't love Lola, but we're training her to kind of like very jealous. Yes. Yeah. Yeah. Can somebody get all the problems right? That's my question.
I'll bet you $5.
I am not taking that bet. For the last one, it looks right. No, not right.
Is this right?
That is correct. How'd you get that though?
I just guessed and checked until it was above.
That's the right way to do it. Yeah. Nope. So the last one is definitely a write out the slots and figure out how many choices you could have.
Is that right?
Yes, good. Yes. We would never have a smaller number in front of a bigger number. This is an example. Oh, it'd be 5P3. Just be flip-flop. So your bigger number's in front of the small. Yes. No, way too many quizzes needed. All it needs to be is like
27, 26, 25.
Oh. Mr. Englander's got it down. He's going to explain it to all of us.
Like if you have 26 questions and like the first 2 are switched, those are different quizzes now.
Yep.
So you can keep having less and less questions if they're being switched in order.
Probably the best way to do
I
it.
don't really know how to.
The best way to do it is to think about how many different types of quizzes can you make for a certain amount of questions?
The lowest number above 27.
Yep.
So 28.
No.
It's just, what's your mathematics?
You have
Wait, Chris, how does it do number 7?
the better way to do the quiz problem question is to think about how many different quizzes you can make with a certain amount of questions.
Oh. And so my original thought was there's 27 questions but there's like 4. Because everybody says in order of like question 1, 2, 3, 4 is different than question 2, 1. Yeah, okay. Yeah, like, that's like a really annoying question.
You did a good job. You're probably the only one who's gotten it right. Yeah, the quiz question problem.
No, it's
Question 10.
Mr. Messenger, is this?
Yes.
Yeah. Alright, sweet. What's your question, Andrew?
No, you don't have 7.
Yes. Oh, you can't.
No, not no. I still have 18
10. 10.
Three options. Oh. Six. Oh, it's the 3 options.
Oh, no, it's 3. You can fuck it all. It's not 6. Oh, half 1, half 2.
3 officers, yeah. Just the same.
My goodness. All right, are we ready to go over these? And then especially go over the tough ones? Oh, we're on a roll. Okay, so here we go. Choose 3 people from 10 possible selections for 3 different things, 10p3. Group of 5 went to the movies. How can they be seated in 5 seats? 5p5, same as 5 factorial. Same as number 1, we're just choosing a captain, co-captain, and secretary, 10p3. The company C, ESTA, has 10 members on its board. How many can be selected for president, vice president, secretary, treasurer? 10p4. Greece, 8 actors, choosing the role of Danny, Kanicki, and Marty, 8p3. No, I know that play. I sang the telephone song to Lola one morning. It just came to my head. I was like, hi, Lola. Hi, Daddy. What's the story? Right, there you go. Pretty cute. Yeah. So, 7p4. Number 7, 3-digit numbers formed from the digits 1, 2, 3, 4, 5, 6, and 7 with no repetitions. Well, 100 to 500. You have either 1, 2, 3, or 4 as the first number. Because you can't have 5 because 523 and 567. Those numbers are too big. So only 4 choices for the first one. The second digit, you have 7 total, but 1 is already being used. So you have 6 for the second digit and 5 for the third digit. Right? Sometimes you need to just take away the permutations and think about it in terms of slots. Math, 4 choose 4 or 4 factorial. So, sorry, 4p4, not 4 choose 4. Okay? 5 reindeer, choosing 4, 5p4, which is 5 times 4 times 3 times 2. Multiple choice quiz. Mr. Englander, what is the answer? 5 is correct. The easy way to think about this is you have 3 questions on a quiz. How many ways can you order those 3 questions? 3 times 2 times 1 ways, right? 3 questions, 1, 2, 3 questions for the first question, then the 2, then 1. So this is 6 total quizzes that you can make from 3 questions. Well, if I had 4 questions, how many total different quizzes can I make out of 4 questions? Well, 4 questions for the first number, 3 for the second, 2, then 1. This is 24 quizzes that I can make. Well, I just want 27 different quizzes. So I wish I could just use 4, but I can't. Instead, I'll use 5, because if I have 5 quizzes, this would be 5 factorial, 5 times 4 times 3 times 2 times 1, which is how many? A lot. 120. So this gives me 120 different quizzes that I could make. I only need 27, but it does mean I need 5 questions on the quiz. How many ways can 3 different vases be arranged? 3p3 or 3 factorial, doesn't matter. License plate begins with 3 letters. Possible letters are A, B, C, D, and E. How many different permutations of these 5 letters can be made? If no letter is used more than once, 5p3. Same as 5 times 4 times 3. Right? All this stuff is the same. 13, a zip code contains 5 digits. How many different zip codes can be made? With the digits 0 through 9, if no digit is used more than once and the first digit is not a 0. Well, the first digit is not a 0, so that's 9 choices. Well, I've already used a number here, so I have 9 choices left from the 10 total digits, and then I have 8, 7, 6. So that's it. Nope. In 10 minutes, we will go take the panoramic picture.